The group 7 elements, also known as the halogens, have 7 electrons in their outer shell. Unlike in group 1, the reactivity of these elements decreases as you go down the group. The halogens are fluorine, chlorine, bromine, iodine, astatine, and possibly tennessine, but tennessine is so radioactive that its properties haven't been fully discovered. The name halogen literally means salt producing, as when halogens react with metals, they produce salts. Because the halogens are all missing one electron from their outer shell, they go around in what are called diatomic pairs. This means that naturally these elements would never be found on their own. They would only be found in a molecule with another of the same element or in a compound with another element. The reason they go around in pairs is because they can each share one of their electrons, and this will give them the more chemically stable full outer shell. The melting and boiling points, unlike the alkali metals, increase the further down the group you go. This means that chlorine will have a higher melting point than fluorine, bromine will have a higher melting point than both fluorine and chlorine, and so on. The reason this is because the elements further down group 7 have stronger intermolecular forces. When a chemical melts or boils, it is because it is breaking some of these intermolecular bonds. This means that the further down group 7 you go, the more energy it takes to break these intermolecular forces, and therefore the temperature needs to be higher to allow it to melt or boil. Halogens can react with other nonmetals by forming covalent bonds. This means that they can share their outer shell electrons rather than taking one or giving it away. Some examples are hydrochloric acid, hydrofluoric acid, hydrobromic acid, and the diatomic molecules. If they react with metals, however, they form ionic bonds instead. Because metals generally need to lose electrons and halogens need to gain electrons, they can do a kind of trade where the metal gives their outer shell electron to the halogen, so that both end up with full outer shells. Some examples of these are sodium chloride, sodium fluoride, potassium chloride, and potassium bromide. If, however, the metal that it's reacting with has more than one electron in its outer shell, the halogen will double or even triple up. Some examples where this happens are calcium chloride, magnesium chloride, and aluminium fluoride. All of these compounds form ions, which are elements with the same number of protons and neutrons, but a different number of electrons. Ions can either be positive or negative, depending on whether they lose or gain electrons. Also, unlike the alkali metals, the reactivity decreases as you go down the group. This is because the more shells there are, the more difficult it is to gain an electron, and therefore react. This is due to the fact that there are more electrons which repel the incoming electron, as like charges repel, and the nucleus which attracts the incoming electron is further away from it. This means that fluorine is the most reactive element in the halogens, followed by chlorine, bromine, iodine, and finally astatine, which is very radioactive and poisonous even though it is unreactive. Thank you for watching this video, and thank you to Ethan and Jamie who helped find some of the information for it.